Hello students, in this video we'll find the Taylor expansion for tangent of x using the Bernoulli numbers. Let's recall from a previous video that x over e to the x minus 1 is equal to 1 minus x over 2 plus the sum k goes from 2 to infinity of bk x to the k over k factorial, where the bk are the kth Bernoulli numbers. The kth Bernoulli number. Great. Okay. Now what I'm going to do is the following. I'm going to look at this function over here. I'm going to look at x over e to the x minus 1 plus x over 2. Okay. If I simplify this, I'm going to get a 2x plus x e to the x minus x over 2 e to the x minus 1, which simplifies to x times e to the x plus 1, e to the x plus 1, plus 1, over 2 times e to the x minus 1, okay? Which I can write as x over 2. I can multiply the top and bottom by e to the negative x over 2, e to the negative x over 2. That won't change anything at all, right? And I'll get e to the x over 2, then I'm going to have an e to the x over 2 plus e to the negative x over 2 over e to the x over 2 minus e to the negative x over 2, like that. Now we can notice that this function over here is exactly equal to the hyperbolic cotangent of x over 2. So this is x over 2, that stays put. Then I have the hyperbolic cotangent of x over 2. So we've just found a Taylor expansion for hyperbolic cotangent of x over 2. So x over 2 hyperbolic cotangent of x over 2 is therefore equal to what? I'm going to write this as the sum, 1, plus the sum, k goes from 2 to infinity, of bk x to the k over k factorial. Now, an important observation to make is that this function, hyperbolic cotangent of x over 2, is an odd function, and this x over 2 is an odd function, so this function over here is an even function, which means I only have even Taylor coefficients. So I can simplify this and write this as the sum, k goes from 0 to infinity, of b 2k, because I know that b of 0 is equal to 1, x to the 2k over 2k factorial. So that's the expansion for x over 2, hyperbolic cotangent of x over 2. Now we do our standard trick. I can therefore use this, I can leverage this to find the expansion for x hyperbolic cotangent of x. This is just going to be what? I'm just going to double all the x's over here. So it's going to be the sum, n goes from 0 to infinity, of b 2k, and then 2 to the power 2k, x to the 2k over 2k factorial. So we get one sort of really nice Taylor series for free with these Bernoulli numbers. That's the Taylor series for x hyperbolic cotangent of x. Now I can complexify this. So if I plug in ix in for x, what will we get? Ix hyperbolic cotangent of ix. Well, let's think about what this would be. What this is going to be is the following. This is going to be ix and e to the ix plus e to the minus ix over e to the ix minus e to the minus ix, right? So what we can do is, of course, we can notice that this is exactly equal to what? This is exactly equal to, I put a 2 over here and a 2i over here, put that i in the overall denominator. This is just going to turn into what? This is just going to be x cotangent of x. This is x cotangent of x, because e to the ix over e to the ix plus e to the minus ix over 2 would be cosine, and then e to the ix minus the x over 2 with an I in the denominator of the denominator would be equal to a sine of x. So I have x cotangent of x, we have cosine of x over sine of x. So if I plug in, so what can we conclude from this? We can conclude from this that x cotangent of x has this Taylor expansion. The sum, n goes from 0 to infinity, n goes from 0 to infinity. Okay, because I know that cotangent looks like 1 over x near the origin, so of course this is well defined at 0, right? And it's going to be what? It's going to be bk, b to the 2k. Then I'm going to have a 2 to the 2k, 2 to the 2k, then a negative 1 to the k, because I to the 2k is negative 1 to the k, x to the 2k over 2k factorial, right? Beautiful. So we get this formula for x, we get this Taylor expansion for x cotangent of x. Now I can use the trigonometric identity. So recall that tangent of x is cotangent of x minus 2 cotangent of 2x. You can easily verify this double angle trig identity, right? That's just a double angle formula for cotangent. in terms of tangent and cotangent. And so now what I can do is I can say that therefore x times tangent of x is going to be x cotangent of x minus 2x cotangent of 2x, right? Now so let's write out both those expansions over there. So what will this tell me? This is going to be the sum. The first expansion goes from 0 to infinity. And then I have a b to the 2k. So I have a b 2k, a 2 to the power 2k, a negative 1 to the k, and then an x to the 2k, all over 2k factorial, minus the sum. Now I'm going to plug in, where x is, I'm going to plug in a 2x over here. K goes from 0 to infinity. b2k, negative 1 to the k, and then I'm going to have a what? Then I'm going to have a 2 to the 2k times another 2 to the 2k. So it's going to be a 2 to the 2k squared, right? So I'm going to have a 2 to the 2k quantity squared, right? Because I'll have two of those, x to the 2k over 2k factorial, like that. Great. Put the parentheses around all these factorials to make sure we're not getting confused with where the factorials go, right? So those are all parentheses around the factorials. All right, now here's the important thing to observe over here. So I observe when k is equal to 0, both these terms are the same. So the overall sum starts where? The overall sum starts at 1, and so what we have, so this is going to be equal to what? The sum k goes from 1, because the first term zeroes out, 1 to infinity of b2k, negative 1 to the k. Then I'm going to have a 2k over here, 2 to the 2k, and then a 1 minus what? 1 minus another 2 to the 2k, like so, x to the 2k, over what? Over 2k factorial. Great. That's the Taylor expansion for what? That's the Taylor expansion for x cotangent of x minus 2x cotangent of 2x. So what can I do? If I divide by 1 power of x over here, I'll have the Taylor expansion for tangent of x. Then we get our final result. So our final result therefore says what? It says that the tangent of x is equal to what? Is equal to the sum. K goes from 1 to infinity. I have a negative 1 to the k. I have a b, Bernoulli number, 2k. I have a 2 to the 2k, and then 1 minus 2 to the 2k. And then x to the 2k minus 1. And that makes sense. When I plug in k equals 1, this is going to be a 2 minus 1. So it starts at x equals 1, which we know tangent does that, over 2k factorial. And this is the Taylor expansion for tangent of x. And we can show actually in the complex plane this is going to be valid for all x less than pi over 2. So if x is less than pi over 2 in modulus, this series will converge to tangent of x. Thank you very much.